the high-level definition of Predict is the cloud-based operating system for the industrial internet.
If you think about infrastructure, it's everywhere, and there's so much of it, and it's such a huge opportunity to do good things for the world.
We help them to digitize the information they have about the assets, we help them to organize that knowledge, and then we help them to derive outcomes and insights from that knowledge that we accumulate.
It's a platform for ideas. This is the beginning. You're going to have the ability to collaborate and build on top of what we think is going to be the industry's leading platform.
Ladies and gentlemen, please welcome Vice President and Chief Technology Officer at GEdigital, Harel Kodesh.
Good morning, everybody. Boy, what a difference the years make. I remember 2 years ago I was interviewing with Jeff Immelt, and I was half-jokingly saying that in 5 years people are going to think about GE as a software company that also builds jet engines and MRI machines. And I think I was a little bit too conservative. It's definitely coming together. I'm the one standing on the stage here, but I have to tell you, I'm humbled by what the team can do. We have great people. We hired awesome leaders this year, and we bring, top talent, top software development talent to GE. If you think about it, with Hima doing the Predict engineering, Darren doing the cloud, Gittes doing program management, product management, Andrea program management, all the people that are working on that, with Richa helping us on the HR and getting all the talent, and Simon making sure we don't spend too much money. I think we have an awesome team that will deliver, exactly what we need them to do over the next, n number of years. If you think about that, that's what the team was doing internally. But while we were doing it, actually Predict is getting sold, and it's showing up in all kinds of interesting people. We are managing smart buildings in San Diego. The system is running gas trains in Dubai. We're looking at managing ships somewhere over the North Atlantic. And we're doing all kinds of factory automation in central US. And just for fun, we also optimize the performance of the rowing team in the Rio Olympics. So all in all, the system is actually taking shape. And this year, we moved from creating the software to creating and operationalizing the software. We're settling into a very comfortable cadence of releases, and every time we do something, every time we have a new release, we solved a lot of issues that we had before, and we introduced new features. And it's going on and on and on, and I'm happy to say that, with the help of our systems like the product management systems, with the fact that we are responding to all kinds of issues in real time, it feels like the machine is humming. So overall, it's, if I had to give you a report card, we are definitely making it in the world. We are emerging as the only solution for the industrial ecosystem. But software doesn't write itself. You need to have people. So this year we have onboarded 19,000 developers. When you think about it, the system actually was only released in February, so it's about 9-10 months old. And we got 19,000 developers. We will exceed the number that we set for ourselves of 20,000 by the end of the year. We wrote 100 new applications. Well, we and the ecosystem wrote 100 new applications. And we started working with 3,000 SI partners. So in terms of the ability, the muscle to go and create solutions, we are definitely getting there. We took the hackathons and the software development competitions all over the world. We had 10 Predict competitions over the last 6 months. 200 applications were written as part of those competitions, and there were 1,000 active participants, and it doesn't show any sign of subsiding. So overall, I think that in terms of both the commercial and the technical activities, it's red hot. What I'd like to do today is actually talk to you about what can be done with Predict. At the end of the day, if you think about what an industrial company needs, they really need 3 types of systems. They need a system of records, such an ERP system. Because companies sell to human beings, they also need a system of engagement, like a CRM system. But the difference between knowledge enterprises and industrial companies is that at the end of the day, the whole operation, the selling, the record keeping is based on the assets. So we need a system of assets. And the assets are a different software structure or different software construct, in addition to the fact that these are big devices, big machines working sometimes in harsh environments and so on. And Predict is that system. There's nothing like it. This is the only system that is open to the public, open for innovation from inside and outside, and still offers you the ability to create, to manage the assets, optimize the operation of the assets. We have gone all the way from making sure that we can get the data into the devices, or from the devices, analyzing it, creating a different stack of machine learning elements that will allow us to look at what we need to do. When you go and create a prediction for assets, you have to make sure that it's a very high fidelity. Those assets are going to be in operation for decades, and they cost a lot of money. So we have more budget at the part of the overall part of creating those predictions to make really good prediction. In fact, we have to make the prediction really reliable. It's not like buying another book, which may or may not be the right recommendation. It's really a recommendation of whether to service something, to take an asset offline, and create something that is important. So a central part of the Predict system is what we call digital twin. It's the ability, you heard about that, Colin is going to come and talk about it later. Digital twins are really the representation of the physical assets out there. And when you think about that, this is exactly where we need to build a different system. We have to ingest the information really, really quickly from what the physical assets is seeing it, a jet engine, an MRI machine, etc., and put it back in the cloud so we can actually do all the machine learning on pertinent data and not have an age data. At the same time, we want to make sure that we can actually create a network. So when a jet engine, God forbid, start losing some performance parameters, the other jet engines will be able to learn about that, and so you get the wisdom of the crowd, except that in this case, it's not really a crowd of people, it's a crowd of assets. So the ability to build those things that is going to be with us for a long time is going to be super, super important as the assets change slightly, they age, they have different parameters, and they start diverging. Every asset we manage separately. We don't need reference manual for all the jet engines in the world. We need the reference manual for that specific asset. And if we can do that, then we will be able to optimize the operation of the industrial ecosystem. The tools, the technology that relate to digital twin is Predict. This is what we've been building. But in order to do that, we have to extend the notion of what Predict is. So this is where we introduced the notion of the Predict system. Last year, we talked about Predict being a cloud-based operating system for the industrial internet. This time, we're talking about Predict as a continuum of compute nodes and storage nodes, all the way from the cloud to the edge devices, through a bunch of gateways, supervisory gateways, controllers. We want to make sure that we can apply the type of application or compute unit in the right place. You have the cloud at one level, which is very cheap on a cost per bit basis, but has some latency. And then you have the controller on the other side that give you very low latency. You can respond to event on the device in real time, but obviously is much smaller, has much more restricted budget for compute and storage. And the question is, how do you optimize the execution of this distributed application in such a way that you can run the right application at the right place at the right time? This is what the Predict system allows us to do. So it brings all the capabilities, and as a result, we see Predict not just living in the cloud, but also living in a bunch of other interesting devices. So I'd like to share it with you. I'd like to invite to the stage Rebecca Lawson, a VP for Product Marketing for Edge Technologies. Rebecca.
Hello, Harel.
Rebecca, so we talked
about
about edge devices, and tell us what's going on in the edge world.
So I'm really excited here to talk about the Predict-ready edge devices. So let me tell you what that really means. So when we say Predict-ready, that means that the Predict system is running in an edge device. And of course, a lot of people say, well, what is an edge device? And an edge device is just something that's very close to the machine. right? So I'll take you through how we're operationalizing some of this.
Okay.
But first, do you remember yesterday when Beth Comstock was on stage and she was talking about ants? And she was talking about...
It was very complicated. I have a degree in electrical engineering, not in biology.
She was talking about the emergent property of ants and how, and other, bees and birds and such. And so what this is, it's like that because what we're doing is we're distributing the intelligence. And so you know how ants can get into very small places. Well, our intelligence is getting into, for example, a sensor here on a compressor. So we have sensors that are now Predix ready, and that means they can run the Predix machine.
So Predix ready, it means that this code, the Predix code is running on...
It's running there, and that means that we can do really interesting things there. So as we get closer to the machine, we can start to bring intelligence to the machine, and we start to see emergent behavior from systems of assets.
Okay.
Now this is connected to a controller here, and this speaks in Modbus, and so Modbus is a language that's used in industrial controls. So this is Predix ready. So that means that we're bringing connected controls, the world of control devices, into the world of enterprise data. So you can do all kinds of interesting things with this because Predix can speak this language, and it's got a pretty good footprint. So you might want to run some apps here, right?
So if I write the apps for this device, do I do it on this device? Or?
No, you develop in the cloud.
Okay.
Pushes down to this device, and then you're going to have options of what data you might want to run here or what analytics you might want to run here, because there's different use cases. Sometimes you need the data and the analytics to run on a controller. Sometimes you want to use a field agent, for example. This was developed by GE, our friends at Automation.
GE hardware.
This is GE hardware. And all of these edge devices will, of course, give you secure connectivity to the cloud. But more than that, more than just the data transfer, they're also intelligent in and of themselves. So you can run small apps here. This is not a large device. But we have a much bigger footprint in some of the gateways that our partners are developing. So for example, this is an HP gateway. It's running Predix, so it's Predix ready gateway. And over here we have a Dell gateway, and this is also running Predix. So this is running a lot of ants, so to speak, because obviously with a bigger footprint than a field agent, you can run analytics right here. So this is important because our intelligence and the insights and the actions that machines can take can now happen anywhere on the network. And that's a big deal because that's what the industrial internet is all about, digital industry is all about. So we talked about the sensors, the gateways, the controllers. Over here, we've got a rack. So if you need a whole lot of compute or you want to run some really big analytics at the edge, you can do it here, and this connects back to the cloud. So now we've got intelligent conversations happening across a distributed set of nodes.
So you have the cloud in our data center, then you have this box on the operator's premise, and then you have the rest of these devices?
That's right. You might want it on premises. You might want it there for security reasons or regulatory reasons, or maybe you just don't want your data to go anywhere because that's how you are. So we're giving our customers a lot of opportunities to write apps and do analytics and bring those insights immediately into their operations. So again, we're going to be seeing this. I love the idea of the emerging machines, the intelligence around machines, and it's going to happen here first.
All right. So what is this puppy? That's interesting.
Yeah, we're saved the best for last. So this is a drone, and this is the door prize, right? For who? Not really. So Predix is running in here. Predix runs in here, and it's going to operate the drone. So we're going to see how this drone delivers incredible value. I know it's fun and everything, but it delivers incredible value to our customers who need to get to a location and do some computing at the location.
So what does Predix do in this drone?
It's controlling it.
Oh, really?
It's controlling the drone. Take off, fly, turn around, do a flip, take pictures, and then come back and land safely.
Okay.
And all the while, it's transmitting data securely up into the Predix cloud.
All right.
Yeah.
So just to take away from it, so everything is running Predix here. There's a continuum. There's a unified developers model. People can go to the cloud, develop the right application, push the right segments of execution to the right places.
Right. So you're developing in the cloud, but you can execute in a distributed manner. And that makes a lot of sense because we live in a distributed world. Just like the ants, right? They kind of have a home base, but you know how they get everywhere? And you think, oh, they can't be that smart. But they really are pretty small. No Predix on the ants, but well, maybe.
No,
we'll
maybe.
see.
One day.
See. OK.
Rebecca,
thank you very much. All right.
It takes a village to build software. We cannot, we are very proud that working with our partners, Ganesan's team, Ganesh and Ramu's team has been running hundreds of proof of concept, over the world, all over the world in the last year. And really, at the end of the day, as Bill said yesterday, our partners are really instrumental to the success. This is not an ecosystem if we cannot actually bring partners to work with us. So I would like to specifically talk about, one of our strategic partners. We've been working with Microsoft for quite a few months now. We announced the relationship by the two CEOs. I think it was in July, actually, so not so many months ago. The goal, and we're working on that, is to put Predix on Azure side by side with our own data centers. So you can go to a region where Microsoft is already operating and get all the value that Predix has. We've been working with Microsoft as a key partner, not just on putting Predix on top of Azure, but on actually building scenarios for companies that have, industrial companies that have a Microsoft fabric that they're running on for IT, and they've been working us on the OT side. So I would like, with your permission, to introduce Kevin Dallas, Corporate Vice President for Business Development at Microsoft. Kevin, give me a hug, man.
There we go. That's a real partnership.
So Kevin and I have been working together back in the old days at Microsoft. You look like a banker. What's going on with the suit?
This is the new Microsoft.
Yeah, okay. Well, shit. I don't. Okay. So, you and I haven't seen each other for 100 years. So what's going on?
It's all going on. So first of all, I wanted to thank you for the opportunity to join you here at Minds and Machines. Just to give you some background, I run business development for IoT and intelligent cloud at Microsoft. And when I say business development, I mean that in a very literal sense. What we're finding is that there's significant investment going on into digital transformation across all the industries that we serve. And that is requiring us to really find different types of partners to deliver these types of solutions. You have partners that have real depth in industry domain knowledge. So this partnership with GE is very important for us.
So when you go around and talk to customers, what do you hear from them on how they would like to see the two companies coming together and bring them solutions?
So Jeff and Satya announced the partnership back in July at our Worldwide Partner Conference. And we had about 20,000 attendees at that event. The news was extremely well received. So we've got a lot of interest from our customers now in terms of how our two companies can come together. What we found is that customers really are not looking for technologies, they're looking for outcomes. And the 4 outcomes that we're hearing about is 1, help us transform our products, deliver our products as a service. 2nd, optimize our operations. 3rd, allow us to really empower our employees to make smarter decisions. And then 4th, really enhance our engagement model with our end customers. So those are really the 4 outcomes that we're seeing. Now, this is really interesting for Microsoft because we've traditionally been a player in the IT space. And now we're being asked to work with our partners and our customers in operations and the digital cogs or physical products of our customers. So very, very different for us, and this is why this partnership is so important.
So let's talk about the partnership for a second. Partnership, you and I have seen it in various places. They're hard to, they're hard to build, they're hard to continue, they're hard to execute on, especially when you have 2 big companies with a lot of aspirations. So how do you, from your point of view, from Microsoft's point of view, how do you see the partnership with GE working out?
So we certainly have aspirations, but at the same time, we realize that in order to deliver to the industry, we really can't do this alone. So partnerships are really important for us. But the first thing I would say, we believe we have a great opportunity to bend the productivity curve. We believe that in order to do that, we have to make the digital twin a reality. We have to really drive OT and IT integration and make that a reality as well. So we are going to be very focused on delivering on that particular promise. Now, in terms of the digital twin, you're all familiar. It is the virtual representation of a physical asset, physical machine, physical device. And there are key elements to that. One is the physics-based model that you heard from Bill yesterday. There's also the data from the digital feedback loop between the physical and virtual. And then last but by no means least, there's this cognitive services and AI capability that's needed with the digital twin that we think we can really drive a lot of value around. So you'll find with our platform, we're delivering huge value there, as well as the digital feedback loop. And then last but by no means least is the integration between IT and OT. Clearly, we have a lot of our own applications, business applications in IT, but we also provide connectivity into industry applications as well. So we really are looking to make sure that we deliver on the promise of the digital twin, as well as the IT and OT integration, and really bend that productivity curve.
Great. Let's see it in execution. Let's see
Great.
some demos.
Okay.
So I would like to invite to the stage Christian Berg from Microsoft and Sanjoy Pinto from GE to show us something interesting. Sanjoy?
Thank you.
Christian?
Yeah, thank you.
So Sanjoy, what are we going to see?
Great.
What is the business that we're trying to solve here?
Absolutely. We're actually solving the problem for inspections for a power line transmission company. So what we've typically seen is a transmission company has about 50,000 or more miles of transmission assets, talking about towers, transmission lines, suspension clamps, insulation, overhanging insulation, etc. And they have to inspect them. So they typically have crews of about 2,000 or more field technicians that go out to these locations and inspect them manually. And as you can see on the screen, it's a very dangerous job, using helicopters and telescopes sometimes to go out to these assets. These assets are typically in a remote location, so it's also cost prohibitive for a company to send out this crew to do these remote inspections. So we are trying to solve this at scale. We are also targeting the problem of the enormous data that comes in during an inspection. So what we do is we use drones like these that autonomously are scheduled to fly out to the asset, get all the inspection data that it can, and bring it back to Predix to store it in the digital asset for that specific asset. So we've completely digitized the asset model to have all the asset data for the power transmission company, and we have at our fingertips the inspection data as well. With that data in digital twin, we are able to run any advanced analytics that we'd like. So we can run efficient image analytics algorithms to identify defects for those assets. We can create work orders automatically and help the customer to do an autonomous inspection rather than a manual inspection, thus reducing overall costs and improving the efficiency of their inspections.
Let's take a look.
Cool. So we look into how we're doing it. Let's select one of the assets in our application. I'll go to a remote location, for example, Stanislaus National Forest. And over there, I can select from a bunch of asset types. Let me select suspension clamps. And I'll select suspension clamp 301. And let's open that. As you see, we have a digital twin representation of the suspension clamp, the ones identified with the red markers there. We know the exact location of that asset. We are seeing that in a map. And I'm also presented with a list of available drones in that area. If I select a specific drone, it'll tell me this particular drone is quite close to this asset and is powered on, ready for autonomous inspections. So I can start a remote inspection right there. We've done a few inspections in the recent past, and I'm going to pull up an inspection we did for the same asset, suspension clamp 301, on November 4th. And as you see on a timeline, we have the data for that inspection along with the images taken. I can zoom in to that timeline, select a specific image. So you see an inspection image for a suspension clamp in the Stanislaus County area. And as soon as we have this data in, we send it through our stream processing engine, and we start the image analytics process, for which let me invite Christian from Microsoft to give details on that process.
Thank you, Sanjoy. For this report, we used Power BI Embedded to provide the analyst with both an overview of the current system's health, as well as a quick means to validate the results of the automatic image analysis. So the automatic image analysis algorithm we built using the cognitive services of the Cortana Intelligence Toolkit. It scans the thousands of images that comes from the drones each day, looking for common issues. And when it finds one, it scores it by severity on a 3-point scale. So for this data set, we can see that we have 1 severity 3, 4 severity 2, and so forth. It also classifies them by the type of issue, which in this case ranges from bird nests in the towers to stabilizers that are misaligned. And here on the map, we show all the images that come in, the location of all the latest images from the drones. And we can here, for instance, click on that level 3 severity image that we captured. What that does is it brings up the original image that the drone captured, as well as an in-focus snippet that the algorithm also creates for the scoring. Now, this is great for the analyst to quickly validate that the algorithm didn't produce a false positive. And if you look closely here, you can see that this is an insulator, and one of the disks here are missing. So it's correct that it classified it as an insulator issue. And it's also correct that it's a level 3 issue, because if the insulator was to fail completely, worst case, the entire tower could become electrically charged. We can then proceed to the level 2 severities by clicking on them. And we see that 3 out of the 4 are located here in Section 2 in the Stansell National Forest. We can also look at the history of issues, and we see that Section 2 has seen a sharp increase in issues over the last 2 months. So if we want to investigate that section further, we can select that here and filter down to it, now just looking at Section 2. And we see these 3 severity 2 issues that we just pointed out. We also see the maintenance history now for this section. You see 2 opposing trends here. On the one hand, the planned maintenance has sharply decreased in the last year, and we've seen a recent spike in ad hoc service requests, presumably in response to the issues that the drones identified. When I click on this issue, this image here, you see that sometimes the algorithm will produce multiple snippets for the same original image. Here, for instance, we see a bolt with a missing pin. Here, this one, it didn't find any issues, right? And you can see why, because the pin is clearly visible here. Now, the pins, of course, are important to ensure that the bolts don't come undone over time. And here, thirdly, we can see 2 bolts in this one image, both of them with missing pins. And in a similar fashion, we can now go through the remaining images, validating the results of the analysis, so that we are confident that when we dispatch the technician, we don't do so in vain. And here, thirdly, the image that Sandra previously showed, and the bolts here in focus with the missing pins. So once we've validated that these are real issues, we can go ahead here and create a work order. What we do now behind the scenes is that we pass Dynamics 365 the asset IDs that we've selected, and it goes to the digital twin model and fetches all of the relevant information to create a work order, which you can see it here created for suspension clamp 301, 304, and tower 305, which had more than one issue. And if we want to see the details here, we can go to the work order section, and here you see the 3 work orders that we just created at the top. And if I want to see additional details about what it added to this service request, I can go ahead and click on it, which brings up Dynamics 365. And here I could also make changes if I wanted to before the before it reaches the technician.
Thank you, Christian. So as you've seen, we were able to completely digitally transform the power line industry. We were able to bring all the assets as a digital twin into Predix. We were able to run analysis algorithms based on the images that the autonomous drone during an inspection sent us. And using those defect analysis algorithms, we were able to find defects, automatically create work orders, and save a lot of money for the power line company.
Very impressive. Well, thank you very much.
Thank you.
Christian?
Thank you very much.
Sanjoy?
Thank you.
Thank you. Wow. That was real code, real product. How long did it take to build it?
Real code. So normally something like that would take months to put together. It took this team 6 weeks.
6 weeks, wow.
Yeah.
So, you know, everything is coming together. The assets from Microsoft, Predict, all coming together to create a unified solution for the customer.
Yep.
So, you know, just in closing, what do you think we need to leave the audience here? What message that they should take away home?
Yeah, I would say that this is a very powerful partnership that we formed here. 2 leaders in our respective areas coming together. We're very focused from a Microsoft perspective and enabling GE in 3 areas. 1, accelerating global rollout of Predix on Azure. 2, driving developer adoption. And the third one, which is arguably the most important, is the integration of OT and IT, that enterprise integration. So when I talk about the accelerate the global rollout, Microsoft has a hyperscale cloud, an enterprise-grade hyperscale cloud that's in 38 regions worldwide. 38 regions. That's more than Google and Amazon combined. We also have data centers, sovereign data centers in Germany and in China. So we can absolutely enable that global rollout in an enterprise-grade, industry-grade perspective. The investment we're making there is huge. I mean, for every single data center, it's over $1 billion. If you look at last year alone, we invested $6 billion in data center build-out. So we're very invested there. In terms of developers, we have hundreds of thousands of developers that target our platform. From this partnership, we're looking to really bring together the Predix services with the Azure services to really deliver the best-in-class platform for developers to build out these new cognitive applications. The types of services we have, services like IoT Suite, the Azure IoT Suite, which processes over 1 trillion transactions, 1 trillion events a week. So it's a proven pipeline for IoT. We also have stream analytics, batch analytics, cognitive services that you saw today for speech, image recognition, all the way through to Cortana for AI capabilities that Bill referenced yesterday. So for developers, there's going to be a rich set of services where you can build these next-generation cognitive applications. Then at the top level is the enterprise and operational applications. How do those integrate? So obviously, we have some very big properties at Microsoft with Office 365 and Dynamics. But we also have connectors into other industry applications as well, like SAP and Adobe. So what you saw today was data being fed into Dynamics 365. But that same data could be fed into other enterprise applications as well. So we focused on enabling that whole connection. And then last but by no means least, we've got HoloLens in terms of the augmented reality capabilities as well. So we're really excited that we're going to be able to bring together the industry's leading platform around OT and IT integration. That's going to allow you to bend the curve. It's going to allow you to really drive business outcomes. And we're looking forward to working with you all and transforming your businesses.
Great. Thank you. I'd like you to take 2 things home if you were dozing during this presentation. First, maybe you were not, but first, the fact is that you have to look at Predix now as the Predix system. The same way that our devices are not working in an air-conditioned room in comfortable temperature, 9 to 5, the system that computes the elements, the application, the software cannot also be only in the cloud. We have to take it all the way to the edge, and that's what we're announcing today. The second thing is that Predix is real, not just in terms of the bits. The bits have been real for a while. The operation, the ability to solve problems, the ability to rev up and respond to any kind of issues or any kind of problem you throw away is also there, and the organization is fully geared up to support you. So with that, I'd like to thank you for the time, enjoy the show, and have a great day. Thank you very much.
Yeah.
Kevin?